Welcome to my Switching, Routing, and Wireless Essentials course. This should be the CCNA version 7 curriculum. This is the second of 3 courses. Okay, Module 3 is about virtual LANs, typically known as VLANs. So in this lecture, we're going to be talking about what a VLAN is, what VLANs in a multi-switched environment looks like, how to configure VLANs, how to allow communication between multiple switches using VLAN trunks, and we're going to talk about how to dynamically set up our trunking protocols. This lecture does not include inner VLAN communication, so talking between VLANs is outside the scope of this lecture. So let's go ahead and let's jump right in. What are VLANs? So we could have a multi-switch environment where we have an accounting department, an IT department, and a human resources department. Well, if we have a switched environment for each one of them, we'd have to have hardware for each one of them. That means additional costs. So what we can do is we can have a logical grouping of switches tied to a physical switch. Essentially what we do is we have 24 ports on a 24-port switch. Well, we can actually virtually say that ports 1 through 5 are in one group, ports 6 through 10 are through a second group, and so forth. That logically breaks up that 24-port switch into multiple logical switches. That's essentially what a VLAN is. It's virtual groupings on the hardware. So what are the benefits of this? It provides better segmentation. It provides better organization and manageability. It provides a restriction of broadcast, multicast, and unicasts as they're isolated within a virtual group, an individual VLAN. The nice thing is VLANs will have their unique layer 3 space, so they'll have their own address space, and that does mean smaller broadcast domains. What is interesting here is if we have a VLAN that requires additional security, like HR or accounting, we can control traffic to those VLANs. And so that's one of the benefits of the separation of traffic. So let's go over some of those benefits again. Smaller broadcast domains, better security, better efficiency. It does reduce the cost of equipment. And it does offer better performance within the switching domains, and it can lead to simple management when you're talking the groups. However, that does mean you need to manage the switch. So simpler management, yes, but network infrastructure management is increased. So again, pros and cons. There are different types of VLANs. We have by default the native VLAN, which is called VLAN 1. This is the default VLAN. And what's interesting is that means everything typically is tagged as the native VLAN. It's the default VLAN. You cannot rename it, you cannot delete it. So here we have a few other VLANs, 1002, 1003, 1004, 1005. If you do create a VLAN and you start modifying these ports, and then you delete the VLAN, the ports do not automatically get put back into VLAN 1. So do keep that in mind. So here we actually do have all of the ports. If you ever do a show VLAN brief and you are missing ports, those ports may have been assigned to a VLAN that were deleted. I say that because that's a pretty common issue that most people don't think about. There are other types of VLANs, like a data VLAN, which realistically most VLANs are going to be data VLANs, and that is basic data traffic. The native VLAN is used for trunking links only. These are where all the frames are tagged as a part of the native VLAN, except for the trunk link. The management VLAN is going to be what type of VLAN that you use for management, but again, it's still a data VLAN. We also have a voice VLAN. That's going to allow for voice traffic. Typically, you're only allowed one VLAN per port. However, voice VLAN is something slightly different. So in your office, you may have a wall outlet of a data port. That data port is actually tied to a switch. Well, that one data port may go to a phone, and then from the phone go to your computer. The voice VLAN will be for your phone. The data VLAN will be for your computer. The port will be assigned a voice and a data VLAN. So this is one of the only cases that allows for two VLANs to be tied to a single physical port. Okay, so we do have a packet tracer showing us how to implement VLANs. Moving on, we have 3.2 VLANs in a multi-switched environment. So how do we get VLANs to actually communicate over multiple switches? That's where those trunks come in, because by default, each switch will have the VLANs only tied to that switch. So we have to be able to have the multiple switches programmed with the same VLANs. A Cisco trunk allows for more than one VLAN to communicate over that connection. It will extend VLANs across the entire network, and by default, it will support all VLANs, and it does support the native 802.1q trunking protocol. That is an older protocol, but that is the current default trunking protocol. So networks without VLANs, all devices connected to the switch will receive all of the broadcasts, all of the multicasts, all of the unicast, well, not all of the unicast addresses, but possibly some additional unicast addresses. They will all be tied to the same network. And the problem with that is that means if one computer is listening, they could receive traffic that might be classified as private. It could be accounting information that you don't want shared with other groups, things of that nature. With VLANs, though, you can configure trunks between the switches, and only those individuals on the same VLAN would receive broadcast and unicast and things of that nature. The devices in different VLANs cannot communicate with one another because this is a layer 3 boundary. In order for one VLAN to communicate with another VLAN, there has to be a layer 3 device because they're different IP addresses. So how are VLANs actually tagged? In a frame, there is a tag section. The tagged section has 4 bytes. 2 bytes for the type, 3 bits for the primary, 1 bit for a CFI, and 12 bits for the VID, the VLAN ID. So the type will be a 2-bit filled with a hexadecimal number. This will be the tag protocol ID. The user priority will be the PRI. The CFI will be a 1-bit value that can support token ring frames on an Ethernet network, not really used anymore. And the VLAN ID basically allows us to have an ID between 1 and 4096 different VLANs. When the tag is created, the frame must be recalculated, and then it's sent to the end devices. The tag must be removed and then recalculated again, and then checked. The FCS is a frame check sequence number used to verify that the frame is not corrupted or damaged in any way. So native VLANs and 802.1 tagging basics. Tagging is typically done on all VLANs. That means even the native VLAN will still tag it as VLAN 1. The use of a native VLAN was designed for legacy use, like the hub in the example. The hub doesn't know how to process it, so it forwards it out everywhere. Unless changed, VLAN 1 is the native VLAN. both ends of the trunk must be configured with the same native VLAN. So one can be VLAN 1 and one could be VLAN 2. It won't work. The trunk will not actually function if they are separate VLANs. So they both have to have the same native VLAN. Each trunk is configured separately, so it is possible to have a different native VLAN on one or both sides. So that's the issue, is when you're configuring them, you actually have to plan out the management of how to set up the switches. It's not just kind of on the fly. So how does a voice VLAN tagging work? So with a VoIP phone, there are 3 ports. The switch will use the Cisco Discovery Protocol. We're assuming it's a Cisco VoIP phone, and it will use that to determine which is the voice VLAN. The phone will be tagged with its own traffic, its voice, and can also use a COS, a cost of service, while QoS, cost of service is QoS for layer 2. QoS is not by itself natively layer 2. The cost of service is the layer 2 variation. The phone may also may tag or untag data from the computer. The ports in the phone will act as a switch. So it will give an access port to the computer that will be allowed to be a bypass. So between this switch and the phone, this is not a trunk anymore. Cisco phones they used to allow this to be a trunk, so they would form a trunk, but that allowed for a different security vulnerability to be implemented. So they allowed a voice VLAN on the switch port, so that this can be a data and voice VLAN. Access to the VLAN can also use a layer 2 QoS priority value. If it is not tagged, then there are no layer 2 QoS priority values that could be assigned. But again, if it's not tagged, it will be the default VLAN 1, even though that should still be tagged. So how do we actually set it up? So when we're planning out our VLANs, we would actually plan out one for voice, one for data. And we could verify by doing a show command and looking at the individual ports. Here we're looking at port 18, so we would do a show interface FA018, type in switch port, and then you will see that it is an access mode, what data VLAN, and it will also say voice VLAN. Nice thing is we do have a packet tracer so that we can observe VLAN communication. Questions, concerns, please reach out. Thank you.